Logs all around. What a beautiful setting. These fallen trees turn into logs, and you see these logs all around the place. Let's enjoy these logs. I'm Anil Kumar. Welcome to my series on logarithms. We are now going to see how to solve logarithmic equations. I have 4 examples here. We'll follow different kinds of strategies, and I hope that will give you a wide spectrum of idea of solving such questions. So the 4 questions here are log to the base 2 of 3 to the power of x minus 1 plus log to the base 2 of 3 to the power of x minus 2 equals to 0. So here you have to apply the laws of logarithm, right? So laws of log. To solve this equation. The second equation seems to be straightforward. Log, that is to the base 10, fifth root of x squared minus 21x equals to 2 over 5. Now when you solve this equation by converting it to exponential form, you should be looking for extraneous roots. That means the solutions may not be perfectly fine when you place them back into the equation. Third example here is log to the base 2 of x, log to the base 4 of x, log to the base 8 of x when multiplied gives you 36. Now since the base are different, we need to do change of base. (16) equals to x to the power of log 2x. Now this is a very difficult equation, and I'll call it as level 2. Now such equations could be solved by taking log both sides. Correct. So these are 4 very important strategies which are normally followed in solving logarithmic equations. I do have a playlist with many of such logarithmic equations as an example, but here's a sample one which gives you overall view. Now let's begin and solve these equations one by one. You can also pause your video, solve them yourself, and then check with my solution. The very first one, log to the base 2 of 3 to the power of x minus 1 plus log to the base 2 of 3 to the power of x minus 2 equals to 1. So applying the laws, we get log to the base 2 of 3 to the power of x minus 1 times 3 to the power of x minus 2 equals to 1, right? So that plus makes it product. Now this 2, we could now convert to exponential form. So what we get here is 3 to the power of x minus 1 times 3 to the power of x minus 2 is equal to 2 to the power of 1. So that changes to the exponential form. Open this up and bring 2 to the left side and then solve it as a quadratic equation. So when I multiply these two, I get 3 to the power of 2x minus 2 times 3 to the power of x minus 3 to the power of x plus 2. Bringing 2 to the left side, minus 2 equals to 0. So that makes a exponential equation in quadratic form. Minus 3, because both are negative, times 3 to the power of x, and that is 2 minus 2, which is 0, equals to 0. Now I can take 3 to the power of x as common. So we have 3 to the power of x common. So we're left with 3 to the power of x minus 3 equals to 0. Now in this equation, each component, each term, each factor could be equal to 0. So we get a solution for 3 to the power of x equals to 0. And we do have a solution here for 3 to the power of x minus 3 equals to 0. Now 3 to the power of x equals to 0 is no solution, right? So here we do not get any solution. because exponential function will only approach 0. They are never 0, right? They are greater than 0. Now in this case, we could solve as 3 to the power of x equals to 3, and that gives you one solution, that x is equal to 1. Correct? So we have our answer, which is x equals to 1. Now it's a good idea to put x equals to 1 and check your answer. So if I substitute x equals to 1 here, then what happens? So let's check our answer. It's a part of solving any logarithmic equation, right? So you may be sure about it. I know it's not really required, but let's still do it, right? So what we get here is log to the base 2. If I write x as 1, this is 3 minus 1, which is 2, plus log to the base 2 of 3 minus 2, which is log 1, and that gives you log 2 of 2 is 1 and anything is 0, so this really gives us 1, so it is true, correct? So it's a good idea to verify. In the first example, I did verify and find that the root is perfectly fine. Now let's move on and take the second example. We are given log of fifth root of x squared minus 21x equals to 2 over 5. So let me rewrite the equation first. Log to the fifth root of x squared minus 21x equals to 2 over 5. So first step is write it in exponential form. So we get fifth root of x squared minus 21x equals to 10, because that is the base 10. 10 to the power of 2 over 5. Now, the fifth root can get cancelled. Let me rewrite this as x squared minus 21x to the power of 1 over 5 equals to 10 to the power of 2 over 5. Now from here, you can say clearly that x squared minus 21x should be equal to 10 to the power of 2, which is 100. Is that clear? So fifth root, inside fifth root term should be same, correct? Now bringing 100 to the left side, it becomes a quadratic equation. So we have minus 100 equals to 0, and that can be factored. 25 times 4. So minus 25, since this is negative, times x plus 4 equals to 0. So that gives us again two solutions. Okay, so let's look into these solutions. So the factor, which is x minus 25 equals to 0, means x equals to 25. And the other one, which is x plus 4 equals to 0, gives us x equals to minus 4. So these are the two solutions. Now let us again check. Checking is a part of solution of any logarithmic equation. So at times you may feel it's waste of time, but it's kind of important. So if I check with 25, we have log of fifth root of 25 square, which is 625, minus 21 times 25. We could take 25 common and then work it out. So log of fifth root of, let's take 25 common, right? So we have 25 minus 21, which is 4, as you know. So we do have log of fifth root of, so this is 25, times 4, which is 100. So we have log of, you can write this as fifth root of 100, right? So which is fifth root of 100. Let me write like this now. And then finally, fifth root of 10 squared, which is 2 over 5. So that works. Perfect. So this solution is perfectly fine. Now let's look into the second solution, right? It seems to be an extraneous root. Some of you must have written it by now. Anyway, it is. So let's see how. So log to the base 5 of, 10, fifth root of x, we are substituting a minus 4, right? So minus 4 squared minus 21 times minus 4. So which is log to the base 10 of fifth root of 16, and that becomes positive 4 and 2, 8. So it is log fifth root of 100, which is log, let me write this as 10 to the power of 2 over 5. So what do we get? So clearly what we get again is 2 over 5. So in this particular case, we find that minus 4 is also the correct root. It is not an extraneous root. Correct? Now for some of you, let me explain why it is not an extraneous root. Now if you sketch this inside function, we need that to be positive, right? So let me, what we need is that x squared minus 21x, which could be written as x times x minus 21. We need this to be greater than 0 for this log to be, that to be within the domain, right? So here is a small sketch. So if I have a parabola, which is represented by this equation, in that case it is positive during the interval when it is less than 0, or it is greater than this 0, which is 21, and this is 0. So any value which is negative could be a part of your solution, as we saw here. So in this particular case, we really do not have extraneous root, and we have two answers. So our answer for this particular question is 25 and minus 4. Perfect. So it is kind of important to check. At times it may seem that it is not a solution, it's an extraneous root, but truly speaking it is not, as we just verified. So let's continue and take up the next example. Now here is the third example. Log to the base 2 of x times log to the base 4 of x times log to the base 8 of x is equal to 36. So we need to change the base. Best is change base to 2. Correct? So change of base formula, I hope you remember. Let me just place this formula here. So if I have log a x, then if I want to change the base to b, then becomes log b of x over log b of a. Correct? So that is the formula. So we are going to apply this change of base formula, rewrite the equation. So we have here log to the base 2 of x. We'll keep it as such. Now 4 has to be changed to 2. So we can write this as log to the base 2 of x over log to the base 2 of 4. Correct? Then the next one becomes log to the base 2 of x over log to the base 2 of 8 equals to 36. Perfect. So we have applied the change of base formula to get everything in log to the base 2. Now, this could be written as log to the base 2 of x times, what is this? 2 square, right? So it could be written as half of log to the base 2 of x. And in this case, it could be written as 8 is 2 cubed, right? So 1/3 of log to the base 2 of x equals to 36, correct? So since 4 is equals to 2 square and 8 is equals to 2 cube, correct? So we got that result. So log to the base 2 of 4 will be 2 and log to the base 2 of 8 will be 3. Correct? So we substituted these two values. Okay. Now that is 6 and we have a cubic thing, right? So we have log to the base 2 of x, and this is whole cube, is equal to, so we are taking 6 to the other side and we have 36 here, so we get 36 times 6, which is as good as 6 cubed. So comparing, we can say log to the base 2 of x is equal to 6, and writing it in the exponential form, x equals to 2 to the power of 6. Do you see that? So that is our solution, 2 to the power of 6. Correct? So we know 2 to the power of 10 is 1024. We could go like this, or 2 to the power of 1 is 2. Then we have 4, and then we have 8, and then 16, and then 32, and then we have 64. So 2 to the power of 6 is 1, 2, 3, 4, 5, 6 is 64. So our answer here is x equals to 64. Correct. So that is how we could easily solve this question. I hope that makes sense. Correct. Now here it is straightforward. There is no need to check your solution since we didn't do any square root or squaring on both sides. Now those square root functions, they do create problems at times. Here is the last question, which is 16 equals to x to the power of log to the base 2 of x. Now this is a challenge question. To solve this, we need to take log both sides. So if I take log both sides, I get log of 16 equals to log of x to the power of log of 2x. Correct. So, and when we take this log both sides, it's a good idea to take it to the base 2 since we could now solve this. So we'll take log to the base 2 on both sides. Do you see that part? Correct. So now the left side becomes a number. Log to the base 2 of 16 could now be written as log to the base 2 of, this is 2 to the power of 4. Correct. We'll apply the power rule, right? So that will come to this side. So we get log to the base 2 of x times log to the base 2 of x. Do you see that part? So we have actually applied power rule to the right side. So this is power rule to get you this. Now that's a very critical step. The left side here is 2 to the power of 4 log to the base 2. So that means clearly it is 4. And here what do we see? We see log 2 of x whole square. Do you see that? So we will square root. And whenever you square root, you get actually plus and minus 2 answers. So that is equals to log to the base 2 of x. And that gives you two possible solutions, which is plus minus 2. Correct. So that gives you two solutions, plus and minus 2. Now, if you look at it, log to the base 2 of x, so x has to be greater than 0. Otherwise, the exponent is not a valid expression. Correct. Log 2 of x is not defined if x is not greater than 0. And therefore, only plus 2 will be the right solution. Correct. So we do have an extraneous root here. So we have solution which is x is equal to plus 2. Correct. So that is how you are going to solve this particular question. I hope that makes sense. So with that, we complete the variety of questions which you could see for any logarithmic equation. There are plenty. So I do have a playlist which will give you good practice. Feel free to check the playlist. And if you have doubts, please post your questions. I hope this video helps. Don't forget to put some likes and your beautiful comments. Thanks for watching and all the best.